Okay, let's take a look at these problems. It said convert each measure into radians and they are in degrees. So we have 225 degrees, and in order to convert that into radians, we are going to multiply it by the ratio pi over 180 degrees. So it's pi radians over 180 degrees. So 225 times pi over 180, we can reduce that. 225 and 180 reduces to 5 over 4. And that will end up becoming 5 pi over 4. And that's in radians, so you don't need to put any units in. All right, let's move on to number 20, or number 2, which is 20 degrees. Multiply that by pi over 180. Okay, 20 and 180 reduce. That becomes a 1. 180 becomes a 9. That's pi over 9. All right, negative 255 times pi over 180. Remember, we're using pi over 180 because we want our answer to be in radians. So put the radians on top. Later, when we want to convert radians to degrees, we'll put the degrees on top because that's what we want our answer to be. But right now, the degrees would cancel out once we multiply these. And 255 over 180 reduces to 17 over 12. So this will equal negative 17 pi over 12. Okay, moving over, negative 140 times pi over 180. That would be 7 pi over 9. And it's negative. All right, times pi over 180. That reduces to 5 over 12. 5 pi over 12. And the last one of converting degrees to radians, multiply by pi over 180. 300 over 180, that reduces to 5/3. That's negative 5 on top. Excellent. Oh, that was fun. All right. Now let's take some radian measure and convert them to degrees. So instead of multiplying these by pi over 180 degrees, we're going to multiply them by 180 degrees over pi. Same ratio, just the reciprocal. And since 180 degrees over pi radians equals 1 anyways, it's just a different way to write the number 1. Okay, the 5 and the 180, that will become a 36. That will become a 1. This pi and this pi will cancel out. So we have 23 times 36, which is 828 degrees over 1. So it's just 828 degrees. Okay, moving over to number 8. We have a negative angle here. Pi on the bottom, 180 degrees on top. Right, the pi's cancel. The 36 becomes a 1, the 180 becomes a 5. So we have negative 31 times 5, which is negative 155. And all of that is over 1, so it's negative 155 degrees. Okay, the pi's will cancel. The 12 will reduce the 180 to 15. And this is simply 15 degrees. Five pi over 9, 180 over pi. The pi's will cancel. 9 will become a 1, 180 will become a 20. 5 times 20 is 100, so that equals 100 degrees. Okay, negative pi over 2. So the pi's will cancel. The 2 will reduce this to a 90. That equals negative 90 degrees. And negative 7 pi over 6. 180 over pi. The pi's will cancel. The 6 goes into 180 30 times. Negative 210 degrees. Okay, the following part says sketch each angle, then give two coterminal angles, one positive and one negative. And it says a 115 degrees. So I can start this off by making my angle 150 degrees. I start off with the initial side, and then the terminal side. So 115 is going to be bigger than 90. So I want to go about 25 degrees past the 90 mark. We'll just call it somewhere around here. So that's the angle. Then give two coterminal angles, one positive and one negative. So finding coterminal angles, you take the original angle. If it's in degrees, you add 360 to it. And that gives you 475 degrees. So 475 degrees would be if we start here, go all the way around 360 and keep going until we get to 475, and then back at the right spot. And now we need a negative angle. So the 115 degrees minus 360 degrees. And that should give us negative 245 degrees. Now, negative angles would be a clockwise rotation. So start here and go negative 245 degrees. You'll end back at the exact same terminal side. Perfect. $350 degrees. That is almost 360 degrees. So there's our initial side, and going almost all the way around, but just staying 10 degrees short of being completely around would be 350 degrees. So coterminal angles, 350 degrees plus 360 degrees is 710 degrees. And let's find a negative coterminal angle. 350 degrees minus 360 degrees equals negative 10 degrees. So those are two coterminal angles, one positive, one negative. Another angle in degrees, negative 40. So negative 40 degrees, our initial side is going to be on the x-axis. Then our terminal side will be 40 degrees down from there. So it's probably not perfect, but it's very close to that location. That's a negative 40 degree angle. Now we can find coterminal angles. So I'll find a positive one first. I'll add 360. And that gives me 320 degrees. So one way to get to this angle would be to start at the initial side, go 320 degrees, and that should end right on our terminal side. And another way to do that is subtract 360 degrees from it, and you get negative 400 degrees. That would be, if we start on the initial side, go clockwise 360 degrees, then an additional 40 degrees to make it 400 degrees total, and end up on the same terminal side. And our final degree, negative 460 degrees. I'm actually going to find some coterminal angles first. So negative 460 degrees. I want to find a negative angle measure that is shorter than that. So I am going to add 360 degrees to that. And I will get negative 100 degrees. So that's a negative coterminal angle to negative 460. Now I want a positive one. Instead of starting back at negative 460, I'm going to start at negative 100. I know that's a coterminal angle, and I'm going to add 360 degrees to it. And that will give me 260 degrees. So negative 460 degrees, negative 100 degrees, and positive 260 degrees are all coterminal angles. And it's a lot easier for me to see what this will look like graphed. If I think of 260 degrees, 270 degrees would be 3/4 of the way around, or negative 100 degrees would be a little bit more than negative 90 degrees. So that should be my angle. Okay, some coterminal angles. Now they're in radians. We're going to keep them in radians. So first I will add, I'll do the coterminal part first. 5 pi over 18. And I'm going to add to that 2 pi. But I'm not going to call it 2 pi. It has a denominator of 18. 18 times 2 is 36. So I'm going to add 36 pi over 18. And that's just a different way to write 2 pi so that it will have common denominators. And that will equal 41 pi over 18, which is a great number, and I have absolutely no idea what that looks like graphed on a graph. But now let's come up with a negative one. So 5 pi over 18, and I'm going to subtract 2 pi from that, 36 pi over 18. That will give me negative 31 pi over 18. And those are my two coterminal angles. But to graph this, I can't really understand where 5 pi over 18 is going to be, so I'm going to convert that into degrees. I'm going to multiply it by 180 over pi. The pi's will cancel. 18 and 180. 180 will become a 10. 5 times 10 is 50. That is simply 50 degrees. And I know what 50 degrees looks like. So here's my initial side. Here's my terminal side. Let's just call it slightly more than 45. And that's my angle. 5 pi over 18, 41 pi over 18, or negative 31 pi over 18. That's all of them. Excellent. Okay, coterminal angles of negative 11 pi over 9. So let's draw it first. So I'm going to multiply that by 180 over pi. The pi's cancel. The 9 and the 180 cancel. That becomes a 1. That becomes a 20. Becomes negative 220 degrees. Well, negative 180 degrees would be the x-axis, so we need negative 220, which is an additional 40 degrees from that. Let's call it right here. Now I'm going to stay in radians when I find my coterminal angles. Negative 11 pi over 9. Even though it would be easier if I just found coterminal angles to 220 degrees, but I want to keep these in radians since we started with radians. So I'm going to add to that 9 times 2 is 18. 18 pi over 9. And we get 7 pi over 9, which is a positive answer. So now I'm going to subtract 18 pi over 9. Which is negative 29 pi over 9. So those are my two coterminal angles. They don't seem like they're very helpful, but there they are. All right, good luck.